What's called mucking out. Huge shovels scoop 14 tons of rock at a time and load it onto waiting trucks. Over 300,000 tons of rock are driven out of this mine every year, but in each ton there may be as little as 5 grams of gold. Getting that speck of gold is a major challenge. The only way to extract it is by leaching the rock with chemicals, but before that can be done, the rock must be crushed. First, the rock is loaded onto conveyor belts. Then it's taken through a series of giant rotating mills. These 13,500 horsepower beasts pound the rock relentlessly, pulverizing it with thousands of steel balls. Water is added to the powdered rock, creating a dirty, ugly slurry. Remember the saying, where there's muck, there's money? Now the chemical extraction process begins, and the first chemical needed is a surprising one: cyanide. It's deadly to humans. It also has the power to dissolve gold. Carbon is then added to the slurry, which absorbs both the gold and the cyanide. So now the gold is concentrated inside the carbon. It's at a much higher concentration than it was before, but there's still nothing glittering yet.
And the gold in our ores is basically invisible gold. It's so small that you can't see it. And we, in fact, never see the gold ourselves until it's poured into those bars.
The final stage of the alchemy takes place in a heavily fortified building. This end of the operation is top secret, and only a handful of vetted mine employees are allowed inside. The gold is now at a valuable concentration. But as yet, there are still no gold bars to be seen. The carbon, cyanide, and gold solution arrives here in pipes and is pumped directly into these tanks. At this stage, each of these baths contains around $500,000 worth of gold. The liquid goes through a process called electrowinning, where steel wool attracts the gold from the cyanide and carbon. The gold-rich steel wool is then soaked in sulfuric acid, destroying everything except the gold. Now comes the fun part. Here, the molten gold is poured into molds, and for the first time, it starts to look familiar.
To pour this gold, as hot as it is, it's actually quite unnerving. If you make a mistake, that gold will splash up. You can't burn yourself. We deal with the finished product. You know, we actually see a gold bar. A lot of people go through their entire life of mining only seeing dirt.
These bars are still only 90% pure. They'll be refined one more time before being sold. Gold mining is a complicated, laborious, and expensive business. No wonder gold is one of the most highly valued objects on Earth. Behind the ordinary is the extraordinary. Coming up, it's the most frustrating game in the world. But don't beat yourself up over your lousy swing. Blame it on the clubs. Next, on How Do They Do It? You're hooking, you're slicing, you're topping. And the entire countryside seems to consist solely of sand bunkers and water hazards. Golf, like life, is cruel. Perhaps it's your preliminary wiggle, or perhaps it's not your fault at all. Perhaps it's those blasted cheap clubs which stand between you and a handicap of 4. Many golfers are convinced that custom-made golf clubs can make all the difference. So what is a custom-made golf club, and does it make a difference? How do they do it? They're one of the most indulgent golf accessories, custom-built clubs, and one of the most famous producers of such clubs is Ping. Now this chap seems to know what he's doing. His swing is controlled but relaxed, and he's wearing those two-tone shoes. But he's over 6 feet tall and using standard length clubs. He'll be compensating for the club length in his swing, which is likely to affect his game. To get a bespoke set of clubs, he must first have his swing subjected to a rigorous scientific criticism. That means hitting balls again and again and again. The golf pro fitter analyzes the swing, measures the player, examines the divot marks on a special mat, and he examines which spot on the club head is most frequently making contact with the ball. Then it's time for the application of some serious 21st century high-tech wizardry. The technology in this tracking system was originally developed for the military, but has now found a far more important application on the golf course. This machine charts the speed, distance, spin, and flight path of a golf ball. At last, cold scientific proof that it was the clubs all the time.
With the club, the way the club is set at the minute, it is causing the shot to come up short and to the right of centre. So, looking at the ball flight, Steve, what we need to do now is change your club.
So let's see how they make a set of pings. You start with several clusters of wax molds, from which the heads of the clubs are to be made. First, the wax molds are dipped in a slurry of white ceramic. Then they're swiveled round to another bin, where they're coated in fine-grained ceramic-based sand, finer than flour. The resulting ceramic-coated molds are moved into an oven to melt the wax interior, and then placed in a second oven, heating them to 1,000 degrees Celsius to be baked and strengthened further. The molds need to be strong because stainless steel ingots, melted at 1,500 degrees Celsius, are now poured into them. Overnight, the molds cool, and the heads are separated, one by one. Rough edges are smoothed out. The heads are then sent here to join the rest of the customized golf club. First, the head is glued on and rammed home onto the shaft. Each club is now individually tagged, identifying the exact specifications of each customer. Then a burst of intense heat to make sure the glue sets and the head stays firm. In this corner, it's time for some more tinkering with the heads. Elsewhere, the drivers and irons are weighed and their centre of gravity is established. The clubs are altered and remeasured to suit each individual customer and swing. The heads of the woods are glued to their shafts. The putter shafts are given the required degree of kink. The shafts are cut to length, and the grips are attached. Finally, each club is given its unique serial number. This allows Ping to keep a record of a club's particular specifications. Back to the scales, and the addition of an extra weight to the head of each iron. The club is complete. But has it made the slightest bit of difference to his game? The moment of truth. Well, he seems to have cured his slice and is hitting the ball further. But how much is down to psychology and how much to the clubs, we shall never know. Whatever. Here's a shot of him hitting the ball, and here's a shot of the ball going in. Marvellous. Coming up, moving stairways, the engineering marvel beneath our feet. Next, on How Do They Do It? Each of us travels on average around 24,000 kilometers a year. But there's a crucial device that links our journeys which most of us hardly notice. It is the escalator. The London Underground is one of the largest underground railways in the world, but it would simply be unable to cope without its 400+ escalators. Each set of electric stairs is able to ferry a staggering 13,000 people every hour. In the London Underground, the workload is punishing. So how do they do it? Here at Coney in Yorkshire, they build around 150 escalators a year, each taking 6 weeks to complete. Each escalator is made to measure for the building where it will be installed. These are destined not for the London Underground, but for the new Terminal 5 building at London's Heathrow Airport, the busiest international airport in the world, where they will help carry 30 million passengers a year, most of whom won't have a clue what's going on beneath their feet. If this factory has a strangely old-fashioned feel about it, it's because building escalators is not a highly mechanized business. You'll find no army of robots here. Coney's designers, engineers and fitters still consider producing an escalator a skilled craft. One of the biggest problems they have to overcome in the building process is ensuring that the stairs run in a straight line. An escalator is a precision tool. On a 20-meter stair like this, there's only a few millimeters margin for error from one end to the other.
Yeah, that's now level.
And to get it right, they don't need lasers or 3D computer-generated models. They just get the plumb line out of the toolbox. The exact center point of the stair run is measured with painstaking accuracy. These measurements are crucial because the central engineering principle behind the escalator is balance. If these measurements